Hello, mathematical fifth grade thinkers. My last video ran a little long, so let's jump right into it. The learning goal for today is I will be able to solve problems using part-to-part and part-to-whole ratios. So let's look at those vocab terms and what those mean. First of all, a ratio, we've just been talking about rates, and we know that rates are a comparison of two quantities, um, such as miles per gallon would be a rate. The difference is that ratios compare two quantities of the same units. So whereas miles per gallon is comparing distance to a quantity or a volume of liquid, we have ratio compares two things of the same unit. So that might be boys to girls because they're both people. It might be heads to tails because that's both referring to a coin flip. Or it might be wins to losses if you're referring to games played. So there are a few ways we can express a ratio. We could say a ratio, the ratio of boys to girls is 2 to 1. We could write it as a fraction. The ratio of boys to girls is 2 to 1. Or you may have seen the colon here. They all mean the same thing. Now, equivalent ratios, we've talked about equivalent fractions, and equivalent ratio is the same idea. So 6/8 and 3/4 would be equivalent ratios. And we can find out if they're equivalent by seeing if their cross products are equal. 8 times 3 is 24, 6 times 4 is 24, so those are equivalent. Now a part-to-whole ratio compares the part to the whole, as it says, so it might be the number of boys to the number of students. So the boys would be the part, and the students would be the whole. Or girls would be the part, and the students would be the whole. Or it might be the number of wins to the total games played, number of losses to the total games played, etc. Part-to-part ratios compare both parts of the whole. So that would be boys to girls, or wins to losses, or heads to tails. So a couple examples here. If a team has won 12 games and lost 9, at that rate, how many wins would you expect them to have if they have lost 15 games? So let's set this up as a part-to-part ratio. Well, one part is that they've won 12, and the other part, so we'll put that on the bottom, is that they've lost 9. And that should be an equivalent ratio, because it says at that same rate, how many wins, so the wins will go on top, just like the other side over here. How many wins would you expect them to have if they have lost 15 games? So the loss is the other part of the whole. So the whole would be the total games played. And we have wins as part of that, losses as part of that. Now we use cross products. 9W equals 12 times 15, which is 180. And if we have 9 of something, we want to divide and find out what 1 of that something is. So 1W then is equal to 20. So you could expect them to have 20 wins if they have 15 losses. Now over here, if a team has won 12 games and lost 9, so the same numbers as here, how many wins would you expect in their first 14 games? So now we're comparing part to the whole. Well, the part could be games won or games lost. But they're asking then how many wins would you expect? So let's go with the games that they've won is the part. And the whole would be the total number of games that they've played, including wins and losses. So 12 and 9 is 21. And that should be an equivalent ratio to the number of wins that they would have in their first 14 games, total games. So that is the whole that we talk about here. And now we have to cross multiply again. So 21W equals 12 times 14. Let's see. 12 times 14. Trying to do this quickly here. 168. And then when we divide by 21, we find that W is equal to 8. So we would expect them to have 8 wins, that's the part, to 14 total games, and that's the whole. Now practice this on your own. Try to set up the part-to-part ratio here and the part-to-whole ratio here, and then solve. Okay, so we have a class with 16 girls and 12 boys. So part-to-part would be 16 girls, 12 boys, and that should be equal to, using that same ratio, we know there are 48 girls. So we had girls on top, so 48 girls over here. And boys, we don't know how many boys are here. So now again we cross multiply. 16b equals 12 times 48, which I thought I did the math here ahead of time. 576. There we go. Then when we divide by 16, find out the number of boys, that other part, is 36. And we can actually look back and see, okay, here there are 3 times as many girls as there were here, so we should expect 3 times as many boys. 3 times 12 is 36. Over here, class has 16 girls and 12 boys, same numbers. At that rate, if there are 112 total students, so that's our whole, that's how many would you expect to be girls? So I'm going to start by having my whole on the bottom. If there are 112 total students, how many would you expect to be girls? So we don't know how many girls there are. We can put that on top. So then we need to compare that to an equivalent ratio, and let's see, 16 girls. We're told that there are 16 girls. That's our part. And then the total will be 16 plus 12. Total number of students is 28. So when we cross multiply, we have 28G equals 112 times 16 is 1792. Then we need to divide by 28. And we find that G is equal to 64. So how many would you expect to be girls if there were 112 total students? 64. That is our part. 112 was the whole. And now you should be prepared to work on your personal goals now, and hopefully you can say, I can solve problems using part-to-part and part-to-whole ratios.